Welcome back, focused learners. Today, we are diving incredibly deep into the ultimate Cambridge mathematics exam strategy, and we are specifically tackling what is arguably the ultimate boss battle of the entire 9709 syllabus, mastering vectors. Now, I want you to think of your upcoming exam paper exactly like a movie script. You are the director, and you need to build your blockbuster answer perfectly scene by scene. You've got to cut the filler, and you've got to keep the action moving forward. Whether you are building those early foundational skills in syllabus codes like 0580, 0606, 4024, or 4037, or even dealing with complex data in 4040, all of that leads right up to the advanced A-level topics here. This explainer is your official, no-nonsense examiner's playbook. We're going to completely transform how you approach these questions. So, get comfortable, grab a notebook, and let's dive right into this.
Listen to this carefully because it's absolutely crucial. A Cambridge senior examiner states explicitly, and I quote, "Mastering 3.7 vectors, specifically the equation of a line, r equals a plus lambda b, is essential for AS and A-level success." Let that really sink in for a second. This isn't just a random topic that might pop up if you're unlucky. This exact topic appears in every single examination series, every single one. It is a guaranteed, high-stakes scene in your exam blockbuster. If you do not know how to direct it properly, you are literally leaving massive marks on the table. It's like walking out of the exam room early. But don't worry, that's exactly why we're here today. We are going to break down exactly what those examiners are desperately looking for and exactly how you can give it to them.
All right, here is our roadmap for today's session. We've got 5 clear acts. Act 1, the challenge. Act 2, the strategy reveal. Act 3, the transformation. Act 4, the interactive workshop. And Act 5, the final system. Let's get right to it.
Act 1, the challenge. We're going to look at 2 hypothetical students, Alex and Sam.
Okay, before we critique our 2 students, we absolutely have to establish the baseline mathematics. We need to be speaking the same language. The vector equation of a line r equals a plus lambda b is honestly beautifully simple when you break it down into its core components. Think of r as any general point on your line. It's your destination. The a in the equation, that is your position vector. Imagine a as your anchor, your starting base camp in 3D space. It just gets you onto the line. Then you have b, your direction vector. This is your compass heading. It establishes the exact trajectory the line is traveling in. And finally, lambda. That's your scalar parameter. Think of lambda as the engine of your car. It tells you exactly how far along that trajectory you need to travel. Forward, backward, fast or slow. It's elegant movement in a mathematical landscape, mapped out perfectly.
So, with such an elegant equation, how do thousands of candidates mess this up every year? Let's take a look at Alex first. Alex suffers from major knowledge overload. When the exam asks a simple question about whether 2 lines intersect, Alex panics and writes down everything they know. They calculate dot products, they find angles between the lines, they write out huge chunks of algebra, but they provide absolutely zero contextual analysis. They are answering a question the examiner literally never asked. Then, contrast that with our other student, Sam. Sam has the opposite problem. Sam rushes the math. Sam sees the 2 line equations, immediately sets them equal to each other, finds a generic lambda value, and totally ignores the specific command words demanding verification. Both Alex and Sam are losing vital method marks. Why? Because their mathematical narrative is completely broken. They aren't directing a clear scene, they're just throwing numbers at a wall and hoping something sticks.
Act 2, the strategy reveal. This is where we decode exactly what the examiners want.
The top-tier candidates, the ones scoring the A stars, understand a fundamental secret. They aren't just doing calculations. They are actively navigating 3 very distinct cognitive domains. First up is knowledge and understanding. This is the basics, knowing exactly what A and B represent like we just discussed. Second is application. This is where you make cross-topic connections. Can you apply your vector knowledge to a calculus problem or a geometry puzzle to boost your score? And third, which is absolutely the most important, is analysis. The Cambridge Assessment Framework heavily prioritizes analytical depth over superficial breadth. You need to be able to evaluate alternative methods, choose the most efficient one, and logically justify your mathematical steps to the person grading your paper.
So you might be wondering, how do you consistently hit those higher cognitive domains under extreme time pressure? Well, you use the Peel framework. Now, you might be thinking, wait, Peel? Isn't that for writing history essays? No way. It is the absolute ultimate method to structure complex mathematical reasoning. It stands for Point, Evidence, Explanation, Link. Your point explicitly states what you are about to do mathematically. Don't just start calculating, tell the examiner your plan. Your evidence is where you present your clear step-by-step working. Your explanation is where you clarify exactly why you are using specific techniques, like choosing simultaneous equations. And finally, your link ties your numerical result directly back to the specific real-world context of the question. You're building an airtight mathematical argument.
Let's put this concept to the test right now. I want you to imagine a standard, generic, messy calculation on one side of a page, and then contrast it against an answer perfectly structured with that Peel framework. The difference is night and day. Notice how the stronger, Peel-based answer explicitly states its goal at the top. It carefully shows the I, J, and K component breakdown. It justifies the solution for the scalar parameter with brief, clear notes. And most importantly, it links that final decimal or fraction directly back to the real-world context, like stating definitively that two submarine paths will or will not intersect. Analyzing and recognizing these subtle structural differences is exactly how you train your brain to write the perfect exam script.
Now, before we continue on to the exact steps to build that perfect answer, I have a quick reminder for you. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, mental alarm bells should be ringing whenever you see a vector question now. Stick to the framework, don't rush. Let's move on to the actual transformation.
Act 3, the transformation. Let's talk about turning red ink into green check marks.
Systematic processing of a complex math question always follows a highly standardized sequence. It's a 5-step blueprint. Step 1, identify. You have to isolate the given information, explicitly pulling out the position vectors and direction vectors from a wall of text. Step 2, apply. Apply the relevant principles. You need to consciously choose the right mathematical method. Are you proving lines are parallel or intersecting? Pick the right tool. Step 3, execute. Execute the analysis with crystal clear working. No messy scribbles in the margins. Step 4, verify. Listen to me, this is crucial. If you found lambda and mu using the I and j components, you absolutely must plug them into the third component, the k component, to prove the lines actually intersect. Step 5, present. Present your final answer using strict conventions and proper terminology.
When you look at a flawed answer versus a perfect answer, the visual difference is genuinely striking. A flawed answer is just a generic, intimidating block of algebra. It completely lacks annotation, it does not tell a story to the examiner. A perfect answer, on the other hand, is a masterpiece. It shows clear working down the page, it uses correct mathematical terminology, it includes that verified execution step, proving the intersection in 3D space, and it finishes with a clear, context-specific conclusion. By making these simple structural changes, you transform what would have been a measly single accuracy mark into a full, cascading waterfall of method marks. You are showing the examiner exactly how your brain works.
Seriously? Stop scrolling. Subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 full grade boundaries. Join them right now by subscribing to @Ace the Exams IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Transforming your approach from mere calculation to logical storytelling is the ultimate cheat code for this syllabus.
Act 4, the interactive workshop. It is time to test your skills under pressure.
Challenge 1 is the data scan. Imagine you are presented with complex positional parameters and scalar variables across multiple scenarios. Maybe it's tracking 2 submarines underwater or plotting 2 flight paths in the sky. Can you extract the core trend under the pressure of a ticking clock? Training your brain to quickly spot scalar multiples, which instantly tells you if direction vectors are parallel, saves you precious minutes in the actual exam hall. It is all about learning to see the actual geometry hidden within the raw data. Don't let the numbers blind you to the shapes they represent.
Let's move to Challenge 2, find the flaw. Imagine a student writes this sentence in their exam. The lines intersect because I solved for lambda, giving a generic intersection point. Boom, they just lost the mark. But why? Well, because solving for lambda using only your I and j components merely finds where the line shadows cross on a 2D floor. Think about that. Just because their shadows cross on the ground doesn't mean that 2 airplanes hit each other in the sky. One could be flying 1,000 feet above the other. To get the mark, you must take that lambda value and substitute it back into the third z-axis k component to prove a genuine physical 3D intersection. You have to verify every single step within the given specific scenario. Generic answers get generic grades.
Challenge 3 is speed writing.
In these exams, precision and speed are literally everything. You don't have time to write a novel. Imagine you need to justify why you used the dot product to find a perpendicular distance. Using the Peel framework, you'd write it like this. Point, I will use the scalar dot product to find the perpendicular. Evidence, I am setting the dot product of the direction vector and the connecting vector to exactly 0. Explanation, this is because perpendicular vectors invariably have a dot product of 0. Link, solving this yields the shortest possible distance for the flight path. Boom, done. 30 seconds. That is exactly how you dominate the paper and impress the grader.
Act 5, the final system. Let's pull this all together into your master cheat sheet.
Before we finalize the system, let's rapidly fire off the top 3 examiner warnings directly from the principal examiner reports. Warning 1. Using the wrong approach for the context. Do not waste time using a complex cross product if a simple dot product is far more efficient for the specific scenario. Work smart. Warning 2. Forgetting format and presentation checks. Mathematical presentation follows very strict conventions. Do not just scribble numbers randomly across the page. Line up your equal signs. Warning 3. Writing answers that are not specific to the scenario. Cambridge's higher-order assessment objectives demand that you evaluate alternatives based only on the specific data provided in the prompt, not on generalized assumptions. So, here is your final answering system, neatly summarized into 3 golden rules. Rule 1. Command word decoding. You must physically highlight the command word before you write a single number. Words like verify, show that, and find all dictate entirely different levels of mathematical proof. Rule 2. Peel framework application. Structure your math like a precise legal argument. Point, evidence, explanation, link. Rule 3. The time management matrix. Deconstruct, solve, and evaluate. Break the complex problem down into logical bites, solve them systematically, and always pause to check if your final answer actually makes physical sense.
Listen, students who actually implement these structured mathematics strategies see an average improvement of 2 full grade boundaries. That's the difference between a C and an A. But here's the catch. The theoretical architecture we've discussed today, the precise definitions, the causal relationships, the cross-topic integration, it all requires consistent, dedicated practice. You have to treat your exam revision exactly like you are mastering a professional skill. It takes repetition, discipline, and practice with our weekly videos to make these frameworks second nature.
Here is your final reminder. Please do not walk into that exam hall without packing these essential frameworks into your mathematical arsenal. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by without having the best possible preparation strategy. Relying on these structured methods is exactly what sets the top-tier candidates apart from everybody else.
Before we wrap up, I want you to reflect for a moment. Drop a comment below right now. What is your target grade for mathematics? And what is the absolute biggest challenge you're facing right now? Is it the 3D visualization of vectors? Is it the intense exam time pressure? Our team responds to every single comment. Think about how you'll apply today's playbook to overcome those specific hurdles. Like and share this video with a study partner who needs to hear this. Keep analyzing, keep practicing. Ace the exams. Your Cambridge success starts here. I'll see you all in the next explainer.